Nicole, right? Can I have your name? Christina. Oh, Christina Jenkins. Can I have a name? Kayla. Kayla. Okay. Have your name? Trevor. Okay. Okay. Good. I'm trying to memorize. Try to match face and name. Yeah. Yeah. So age, but maybe 30 or over 25 or 20. It takes time to match face to name. But we have just 8 and Macon 3. So the Macon, can you hear me? It's good. Sounds good. Okay, let me start. Okay. Good. Okay, let's get started. So, where is it? So, first of all, good afternoon. How are you doing? It's good. Okay. So, just try to take a look at the syllabus. So, we are here and continuously we'll talk about the data, the model, how to create, the, how to do, the, how to make a modeling, database, the system. So we'll more take a look at deeply about data model. So the last week we'll just discuss about a binary relationship, and there are 3 relationship: binary, unary, and then ternary, and each relationship one-to-one, one-to-many, and then many-to-many. So we just camera. See. So we'll continue the others, the unary and then ternary relationship. Okay. So what is the binary relationship? Do you remember? Yeah, so number of entity involved are 2. In other words, the degree is 2. I will talk about the degree, the terminology. The unary means only one entity is involved in these relationships. Okay, so the binary, ternary, relationships. So you learn about this, and then we'll take to unary. Okay, it's the same. There's a one-to-one and one-to-many, and then many-to the many. Binary same. Okay. So think about this case. So before make a model, what should you do first? I repeated it a couple of times. Yeah, so the roughly terminology is requirement analysis. In other words, to fully understand the business model of the company of the target system. So in that case, this is a one-to-one unary relationship. So there's a one salesperson entity is involved. But in this company, there is the backup system. For example, the salesperson are organized in pairs as backup. So two person each other when it's away from the work. So we have to include these relations in the EL diagram. So just one entity, but from the, for example, the Nico and Christina, right? So the Nico's backup is Christina, and Christina backups are Nico. So we have to include that relation. So one person backup and the other salesperson is backup by this person. Only one person's match. So it's a backup system, especially in this example. But depends on the situation, depends on the business environment. In that case, it can be changed, this cardinality and the modality. But in this case, just one person is a backup. So one entity, unary, and then one-to-one. So this is a one-to-one unary relationship. And how about this one? One-to-many unary relationships. What is that? Salesperson. And this is there are a lot of salesperson. So maybe one person is a sales manager. That means from the point of the sales manager has the manages many salesperson. So one, sales, yes, the manager manages the many salesperson. This is a many. Vice versa, from the point of the salesperson, I have only one sales manager, not two or three or more. Only one sales manager manages me. In that case, salesperson is managed by only one person. So this is a one. This is a one to the many, this case. Okay, but this is an inner symbol. This one is a zero. That means sometimes Nicole is just promoted today to the sales manager. In that case, she doesn't have any salesperson to manage. So it can be zero. So it can be different. It can be different depending on the situation, business policy, rule, and so on and so on. Okay. Anyway, this is a one-to-many unary relationship. How about this one? Many-to-many unary relationship. This is a product, and there is a component. Can you tell me what kind of relationship is included many-to-many unary relationship? Only one entity is. This is the entity, the product, component. It's the same. Product and component the same. Take a look at this example. So this company, General Hardware, sells a lot of tools. For example, hammer, wrench. So this company make a set as a set, including hammer and wrench. It's called the set B. Okay, and also there's another tool, screwdriver, and create another set A, including set B plus screwdriver. So this is a set A and this is a set B. In this case, set A has many the tools, this, such as set B and the screwdriver. So it has the many product components, but vice versa. From the point of the B is only included set A, and screwdriver is only included the set A. So it's a part of set A. So this is a set A and this is a set B. In that case, set A and the set B and screwdriver, they are also the product. They have the product number and the price, product name. They have the same attributes. But depending on the point of view, set A, it can be a set A and it can be a set B. And this is the first one. And the other second case, set B and hammer and wrench relationship. So in that case, this is a set B. Set B include two tools, hammer and wrench. So product set B has multiple product, hammer, wrench. And hammer and wrench also included to the set B. Okay, so one relationship is this one, set A, set B. And the other one is set B, hammer and wrench. All entities are same entity, the product entity. But depending on the point of view, we have too many relationships. Make sense? Maybe a little bit complicated this part, too many. Okay. Okay. So next one is ternary relationship. It's more simple. How many entities are included? Three. Yeah, three. Salesperson and customer and product. And what is the sale? What is called sale entity? You remember? Title, associative entity. Okay, so associative entity are it exists only a many-to-many relationship. Okay. So salesperson can sell many products, and the many products can be sold by many salesperson. It's many-to-many. Okay, so this is associative entity. 1, 2, 3. The distinct entities are included ternary relationship. So unary, binary, and ternary. Based on this relationship, we are able to draw the full ER the diagram of your system, of your target system. So this is the summarized version of the terminology relationship. So in that case, we'll take a look at the more detail. Okay, so some parts are duplicated, but the other parts are the new concepts. Okay. Data model. What is the data model? Just remind you. It's kind of blueprint for database. design. What is a database design? Before that, data model, kind of the generalized and abstract. Then a database design. And okay, so sometimes if the change is necessary or your customer asks you, I'd like to change my model. You have to add this function, you have to add this entity, and two entities, there are some relationship, may your customer ask changes. In that case, so the data modeling, it is the easier change the data, change your systems than database design. It's similar to programming. When you make or create a software or develop the program, maybe you have to analyze requirements and then design what kind of class, what kind of data structure I will use, and then what is the size of the data, what kind of, after that, you code, typing a code to implement. But after finishing implementing your program, after that, you have to change, you have to uh, redesign and then reprogrammed. It takes a lot of time and resource. But before programming, if your customer asks, I have to change this part, I have to change this part, add function, add class, something like that. In that case, you can just change the model. After that, after fixing, you can implement. It's the same. So it's easier to change the data, the model, than design. So usually there are three steps: conceptual design, logical design, and physical design. Conceptual design is the modeling your data, model entity, and then relationship. And logical design is based on your ER diagram. You can create a table, you can create a database, and you can apply for normalization to reduce redundancy. And then set or the reset the primary key and foreign key, then composite key, so on and so. And then after that, the physical design is what kind of database, hardware are we gonna use? Hard disk drive, I will save the data, SSD, or maybe a flash drive. And the performance, we have to also to consider performance. In a logical design, usually normalization remove all redundancy. I will talk about later about redundancy. But so normalization makes your the model fancy and clearly, but sometimes it's related to performance. Usually the join statement. The join means to connect several the table. So it takes time. So takes time means it related to performance. So if you think performance is much more important than the design, the database design, we have to sacrifice the, the normalization. To think about more the performance. In that case, we have to do denormalization in the physical design. Okay, we'll talk about later about this. Okay, so data model, the modeling of data is equivalent conceptual the design. Okay, and EL, the diagram, entity relationship diagram. So that EL diagram is developed by 1976, okay? So by Peter Chan. So this is the paper introduced about the EL diagram, 1976. So when you can just Google it and you can find this paper. So something like that, introduce the DL diagram, something like that, okay? But it's not enough, so it is extended. So currently we are using the extended, the EL model, okay? So similar, but the newly added parts are in the extended EL model, okay, diagram. And what is the entity? Entity is something or thing identified, and they usually want to keep track of the data, okay? Terminology. And there are two, the sub-terminology, entity class, entity instance. What is a class and the instance? If you take the Java class or the Python class, key value, yeah, key value is a kind of data structure, like a dictionary data style. But when you take a look at the object-oriented programming language, we have about the class, right? And about instance. Or sometimes it is called the object, depends on the textbook. Okay, so class, instance, or the object. The class is kind of blueprint like that. This is a database course. So data model. What is the data model? So customer. Okay, the customer has 1, 2, 3, 4, 5, 6, 7, 8, total 8 attributes. Okay, the name, address, contact name, email address, and so on. So I'd like to keep track of those kind of data of the customer. And actually using these entity class, we have to add the actual data using that entity. So what is that? 1, 2, 3, 4 is a customer number, and then name and address, email, and the second one is 99890. It's a customer number, different address, and a different email address. So based on the entity, the class, like that, actually we are able to add specific data. Nicole, Christina, Caleb, and Wilson, right? Trevor, and other students, okay? That is the instance. But there's a more, the meaning of the instance. All the computer system, especially based on the von Neumann system, every data should be loaded where? Memory, right? And the database, MySQL, also the program. So when you run the database system, all programs and data should be loaded on main memory. So if I use the main memory, the operating system allocate the specific area of the memory, and we are able to, using that memory area, we are able to store and then do something using that memory area. So you design the class, customer class like that. Okay. And then if we want to store the first customer, second customer, third, and so on and so on, they are loaded into the memory. So memory. And allocate specific memory area, and customer wants data stored there. Customer choose data stored in a different memory area. Those kind of things are called the instance. The thing loaded into the memory is called the instance. And actually, this is a memory, and the specific data of the customers are stored there. Make sense? Okay. So this class and instance is the same concept in object-oriented programming language. Okay. Attribute, you know that attribute is entity's characteristic, name, ID, address, GPA, what else? Anything, the courses, something like that. So in the original EL diagram, the attributes are shown as ellipses, but later it's changed using the rectangle, the symbol form. So in the original, the EL diagram, this is the entity, name, employee, using ellipses. They are shown like that. This is a original form, but it's changed to the rectangle form in extended. So entity name and attributes like that. So when you take a look at later EL diagram, if you have those kind of the diagram, this is the original form. It's the same, equivalent to this form. Okay. And identifiers about primary key, foreign key, and candidate key, and also there are and so on. There are a couple of the identifiers. So we will learn about the next time. Okay. And so usually simple is the best. If you have a one entity, just a one identifier is good. But sometimes one identifier is not enough. In that case, we have to use two or more attributes as our identifier. Remember? Associate so primary key of the associative entity. How many attributes are used for primary key? Two, right? One is from salesperson, and the other one is from the product. So this is called the composite key. Okay, or three or four or five, depends on the situation. Okay? Another variation on level of entity attribute display. Sometimes you can see those kind of entity with all attributes. It's a normal form. Sometimes entity with identifier attributes only, the primary key only. But sometimes only the entity name. Okay, so it depends on. Then the relation is the same. Relationship classes and relationship instance. Another terminology is a degree. Degree is the number of entity classes in the relationship. So binary case, two entities are used. So that means degree is 2. Ternary, how many entity? 3. So degree is 3. So that the degree terminology can be widely used, like graph theory, something like that. So maybe, have you ever taken database, data structure and algorithm analysis? No, not yet. Maybe if you take later, if you take the database, in the end of the database data structure course, you will learn about the graph data structure. Okay, so maybe Atlanta, the Macon, and Warner Robins, and what's that? The Seattle, they are connected like that. So this is a node, and this is a link, and the degree terminology also used. So, for example, Atlanta node has 2 links. That means degree is 2. Maybe it's a Boston here, like that. The degree is 3. So that terminology widely used in the graph theory. Okay. Anyway, so 2 entities and 1 relationship, binary relationship, and the ternary, client, project, and architect. Okay, note that. Then, so principal difference between entity and a table, or in other words, the relation. So in the relation database, we will create a table. So, but another name of the table is a relation. That's why we call relational database. Okay, the same word, table and relation. Anyway, so difference between an entity and tables in our EL diagram, we don't have to identify this is a primary, this is a foreign key. Just can draw this is entity and this is entity. Just draw maybe something like this. You don't have to add the foreign key. But when you create a relation or the table using SQL, the language, we have to let you know this is a foreign key, this is a primary key, this is primary key, this is a foreign key, something like this, to connect to tables. Okay, but ER diagram, we don't have to add the foreign key, only just to draw a line. Relationship shows the relationship. Cardinality. What is the cardinality? You forgot everything. The cardinality is the maximum number of relationships. Okay, and minimum cardinality, in other words, the modality is a minimum number of relationships. Okay, so take a look at the maximum cardinality. There are 3 types of the cardinality: one-to-one, one-to-many, and the many-to-many. So remember, in a relationship, this is 1, This is another one. Relationship. Uh, what does that mean? The outer, the symbol. This one and this one. Outer symbol. This is a cardinality. Maximum number of occurrence between two entities. About inner symbol here and here. There is a modality, minimum number of occurrence of between entities. Okay. Here, so outer symbol, cardinality, inner symbol, modality. Modality means the minimum cardinality. Okay, so when you take a look at the symbol, this is a modality, minimum, the outer means maximum. Okay. This is another representation. Okay. So I'd like to show the different kind of the diagram, because when you take a look at the ER diagram somebody created, you have to familiar with, this is another representation of the ER diagram. The ER diagram can be already be changed who designed this system. Okay, so employee and the batch, one and one, one to one. This is a one to one, two entity, the binary relationship. Make sense? Okay, one to n, one to m is a one to many binary. N to m or m to n is a many to many binary relationship. Okay. Then, especially one to many relationship like this, employee and the computer. So one to many. So the entity on the one side of this relationship is called parents entity, or just parents. The many side is called children or child, like that. So here, employee can has the multiple computers. So employee is a parent entity. How about computer? It's a child entity. Okay. So this relationship is called has a relationship. Has a relationship. Vice versa, there is another relationship is a relationship. So that is a relationship is related to object-oriented programming language, especially inheritance. Later, if we take the OOP course, we'll learn about the inheritance and the polymorphism, something like that. And also has a relationship, in other words, a composition relationship. Okay, but it's not important, just for your information. And this is a has a relation, one to many. One is parents, many side child. Okay, and then modality, minimum cardinality, like that. So usually it has 0 or 1. So there are specific meaning. Take a look at. Zero means optional. It should be or not, vice versa. And one means must be exist between two entities. That means it's a mandatory, must. Okay. Or inner symbol, the minimum the relationship. Okay. Okay. The same. Okay. So in this diagram, the one-to-one represents maximum number of relationship, and these symbols the minimum number of relationship between two entities. This is a cardinality, this is a modality. And one-to-many, optional, optional, maximum, optional, and that is what? Mandatory. That means employee should have only at least one skill. For this example, or vice versa, skill, for example, climbing. Can you climb? Rock climbing? Can you do the rock climbing? But this is one of the skill, but nobody can do that. So it can be zero, optional. That's why it's optional and then mandatory. Or you can put like in this style, inner symbol and the outer symbol. Okay, so different representation of EL diagram. Okay, yeah, this one. Maximum, minimum, minimum, and this is a maximum case. Okay, get used to two different style. Okay. And also, when you take a look at the symbol, the meaning is that one means, the inner symbol one means mandatory. Okay, the outer symbol is just one. And one profit, so mandatory and many. And zero, one, optional, one, zero, profit, optional, many. So when you take a look at those kind of symbol, you have to understand what does that mean between two relationships, two entities. Okay? If you know those relationships, you can draw the ER diagram of your target system. Okay. In the end of the class, I'd like to give one the practice to draw the ER diagram. Okay. So get used to familiar with those kind of things. Then many to many and it's a similar. So many to many, optional, mandatory, and inner symbol and outer symbol. Okay. So any questions so far? No? Just check the Macon campus. So it's good, the Macon. Okay, thank you. So there are a lot of the terminology you have to memorize or you have to get used to, right? Okay, so far we mentioned entity, but depending on the characteristic, there are a couple of different entity type. One is that, what is that? Strong entity and weak entity. So strong entity is the entity represent something. Important part is can exist on its own without any help of other entities. For example, uh, student, faculty, building, automobile, and so on and so on. It can be exist so on its own, but sometimes the entity should be existed with the help of other entities. Think about that. This is a building. This is our academic service building. And what is that? The next building is a Thomas Hall, right? And this is Oak Hall, right? So, and each building has several classrooms, 214, 219, 212, and so on and so on and so on. So think about that. The building can be exist without classroom, about vice versa. Classrooms can be exist without the building? No. So in that case, the classroom entity should be exist if the building entity is exist. Okay? In that case, the classroom entity is called a weak entity. The building itself is a strong entity. Okay? In that case, we'll identify strong entity and the weak entity. So weak entity is entity whose existence depends on the presence of another entity. Okay, we'll give some example. And another one, ID dependent. What is that? ID dependent entity is also weak entity, but a little bit different. What is different? The identifier of child entity includes the identifier of parents entity. Okay. See. Okay. Take a look at the first example. Building entity and the apartment or classroom, similar. Okay. So the building has a building name. The building name is primary key of this entity. And the apartment and the classroom. Classroom belongs to the building. That's why the classroom has a building name and the classroom number. This is our academic service building, and this is a 214, and the Thomaso, and there's also 214. So to discriminate, to identify a 214, which 214 classroom, academic service building, or the Thomaso, we have to add building name and then the classroom number. So the building name is added to the attributes primary key of the weak entity classroom. So building name is used here. In this case, it is called ID dependent entity. Make sense? Okay. Okay, so ID dependent entity is building, apartment, painting, print. So the last one, explain later. Identifying relationship. There are two different types of the relationship. One is that solid line. The other one is dashed line. So the dashed line is to connect between strong entities like student, the faculty, they are strong entity. So in that case, we use the dashed line. Or non-ID dependent weak entity. Okay. In that case, we use dashed line. But ID dependent entity, we use a solid line. It's called identifying relationship. The other one is non-identifying relationship. So the same example. So apartment or classroom is dependent on what? The building. This is ID dependent entity. So use what? Solid line. Okay. And painting and print. The print is dependent on painting. So solid line. Patient exam, solid line. So weak entity, ID dependent entity. Okay, we use solid line. And also compare the entities, this one and then this one. Can you see the difference between two symbols, two group of symbols? Top and the bottom. What is the difference? Sorry. Yeah, shadow boxes. Yeah, yeah. The tops are the strong entity. What is that? Rectangle corner, which means, this is a parent. This is a strong entity. But ID dependent entity, what? Rounded corner. So when you take a look at the ER diagram, this is a rounded rectangle. This is a ID dependent entity. It is dependent on some strong entity. You can guess. Okay. Mm, 10 minutes. So here we just have ID dependent entity, vice versa, non-ID dependent entity. So there are a lot of entities, right? What does that mean, the non-ID dependent? Take a look at this example, left one, ID dependent entity case. So strong entity, it's a car model, and ID dependent entity is a vehicle. So when the manufacturer make a car, first of all, you can design the entity automobile. For example, I'd like to make the pickup truck. Maybe you can add some attributes, something like that. And then based on the pickup truck, the data model, there we can make a variation, F-150, F-250, F-350, and so on and so on and so on. So the specific vehicle is belongs to the kind of the concept car, concept model. That's why this is a weak entity. But to identify the specific model, F-150, 250, and 350, the manufacturer and the model, the primary keys are used as the primary key in their ID dependent. But sometimes 1, 2, 3 or more, they should be combined to identify F-150, 250, 350, or 450, 550, and so on and so on. So instead of those kind of thing, we can use like the bin number. So when you take a look at just the bin number, this is F-150. This bin number, 250. This bin number, we can identify using the bin number. So replace those the composite keys by only one the key, primary key. But still, this vehicle belongs to the strong entity. Without the model, we cannot create the vehicle, right? So relationship is still dependent, but the ID, identifier of strong entity are not used anymore in their weak entity. So in that case, it is called non-ID dependent weak entity. ID dependent identifiers of strong entities are used in the weak entity, but still the dependent relationship identifiers of strong entities are not used anymore. So non-ID dependent. Make sense? Okay. So just a summary. Weak entity is entity should be depends on another entity. ID dependent entity is weak entity. Identifier include the identifier to another entity. The identifying relationship using solid line. Okay. Just subtype. Just look at the subtype. Another entity is a subtype. So there are two different subtypes, exclusive or inclusive. So subtype entity is a special case of another entity. So think about that. Student. So there are two types of student. Undergraduate, they graduate, right? So undergraduate is also a student. Graduate is also a student. So student has a common characteristic, common attribute, ID, name, and so on and so on. Make sense? But depending on the undergraduate or graduate, we have to identify Nico is a PhD, or Christina is a master, Caleb is a undergraduate. So we have to identify depending on the status. So in that case, we add one attribute. It is called a discriminator. And then, so using this discriminator, divide into undergraduate and then graduate. But still, they are student. So those are called the subtype, undergraduate subtype, and then graduate subtype. Student ID is what? Our student's identifier. We have to use students, the PK to the subtype PK, student ID. Make sense? But exclusive means two students must be undergraduate or graduate, right? So we can have those symbol, exclusive the symbol. That means every student should be undergraduate or a graduate. There's no other cases. Make sense? But inclusive case, for example, the club or students can join hiking club, can join sailing club, can join rock climbing club, or both, or the multiple club, okay? Or nothing. So in this case, it is called inclusive subtype. Okay. So the university system should have those kind of relationships to identify undergraduate and graduates. Maybe PhD student, we have to add undergraduate, the master, and then PhD, divided to three subtypes. Okay. So one more thing, the supertype. So in that case, those are called the subtype, and this is a supertype. The supertype has to be in one of the subtypes. The subtypes are total subtypes. The other one, supertype does not have to be in any of the subtype. It is called the partial subtypes. Two different types, total or partial. Okay? And then relationship between subtype and supertypes are called is a relationship. In other words, inheritance relationship. Okay. In the OOP programming language, the inheritance concept used when is a relationship. And then the value inappropriateness, for example, undergraduate takes and report SAT, graduate takes and report the GMAT or GRE. Okay, so for graduate, SAT score would be null for graduates. GMAT score would be null for undergraduate students. So in this case, the score on GMAT should be null for undergraduate, but score on SAT should be null for graduate students. Okay, use those null value. So just summarize. This is a one-to-one, and then dashed line means non-identified. That means entity A and entity B are what? Strong entity. Okay, and one-to-many, and A and B are strong entity. Okay, then many to the many. The dashed line is strong and strong. Okay, and then one to many. This is a solid line. That means this is a strong and this is a weak. Okay. Similarly, this is a exclusive, the subtype. This is inclusive, the subtype. Okay. So this is the meaning of the different symbols. Okay. Just a minute. Okay, I have give one question practice. Okay. Yes, this is empty sheets. The others, okay, can you pass? Yeah, just pass. You can take one and the pass. Mhm. The American campus can take a look at. I will add post the chat, the file. Just a second. Fetch file from the file. Let's see. So Gregory and Kadiwanashi, can you see the file that I just a second, posted into the chat? You can download and open that document. Okay, so in a document, there are descriptions. Okay, so the Lockheed rental car business environment. Okay, so read. So this is just very the simple the case of the system. And then when you have those kind of description, you have to list what kind of entity are needed to make database for this environment, business environment. So to save the time, I list up entity, the necessary entity, and maybe the examples of the attributes, something like that. So take a look at these entities and attribute, and then read the description and try to draw the ER diagram. Make sense? Okay. So I passed the empty the paper. You can draw. Do you need a pen? Okay. Just a second. Anybody need a pen? One, two, two. Okay. Think about the relationship between the entities like car. So, yeah, just to check it's working. Okay, it's good. Yeah, okay, good. Mhm. Gregory, Tajiwanashi, can you hear me? Okay, you can download the file and then try to draw the EL diagram of this practice. Read the description and then take a look at the entity and attribute. And then using those two data, you can draw the EL diagram of this lucky car. What is the name? Lucky car, the business environment. Okay, so how many entities are needed in this EL diagram? No. So how many entities are list of 5? So means in a EL diagram, how many entities should be included? 5, right? And then you have to add what? Relationship. Okay. For example, car manufacturer. So in order to understand the relationship between entities, you have to read this description. Maybe car was manufactured by exactly one manufacturer, this is a kind of the hint between car and manufacturer. Okay, you can find the hidden meaning. So those kind of description can be obtained by interview or document and investigation of the company. Okay. Yep. Mhm. Yeah, it's a kind of the one representation, and the other one is, oh, you don't have the paper. Oh, there's an empty one. Ah, so you can do that like that, but I'd like to recommend you this one. Like, can I have like maybe this is a manufacturer, something like that, and then the manufacturer that attribute. So you can write the attribute over there, and it'll be the car, and this is a primary key, and then attribute, and then you can use the profit relationship. For example, this is relationship between the manufacturer and the car. Again, you can add the inner symbol and then outer symbol, the cardinality and modality. Not an answer, just an example, maybe something like that, or something like that. Okay, you can draw like this, and then you can add some more the description. Manufacturer makes car. Car is made by the manufacturer. Something like that. I think better than this one is better than this one. Mhm. Can I have your name? Sure, sure. Okay, thank you. Sure, sure. Trevor. Trevor. Yes. Okay. Can I have your name? Isabella. Okay, Isabella. Maybe next week I will forget. Then I will ask again. Yeah. Nicole. Can I have a name? Tiffany. Okay. Tiffany, Nicole, Trevor, Caleb. Padre? Teatre. I'm sorry. Teatre. Christine. Okay. Okay, guys, it's time's up. So let's call it a day. And then about this, maybe if you have a time, you can do at home if you have time. Okay, it's not at the homework or any quiz, just for your practice. Okay, so about the complete the EL diagram, we'll take a look next week. Make sense? Okay, and then thank you, and then have a great evening, and then see you next week. And thank you, Macon. So see you next week. So we'll take a look at the full the ER diagram of this practice. Okay. If you have a time, you can do at home for your practice. Okay. Thank you. Any questions in the Macon campus? And also, I upload this the recorded class into the D2L. Oh, thank you. Mm. Thank you. Gregory, do you have any questions? Oh, yeah, yeah, in the inside the box. Mhm. Mhm. Thank you. See you.